8.1 Graphing simple rational functions. How are the graphs of f of x equals a times 1 over x minus h plus k and f of x equals 1 over b times x minus h plus k related to the graph of f of x equals 1 over x? These other two are transformations. They are transformations of f of x equals 1 over x, of the graph f of x equals 1 over x. Remember that h is always the horizontal, left or right. K is always the vertical, up or down. And then the A will either stretch it or compress it vertically, and the B will either stretch it or compress it horizontally. Graphing and analyzing f of x equals 1 over x. A rational function is a function of the form f of x equals p of x divided by q of x, where p of x and q of x are polynomials, where q of x is not equal to 0. The most basic rational function with a variable expression in the denominator is 1 over f of x. Okay, it says state the domain of f of x. Well, most of you probably don't know what f of x looks like, or 1 over x looks like. So let's draw some quick little one real quick. And so here's our, well, that doesn't look very good at all, does it? So let's see here. Well, let's see here. We'll make this a solid line. We'll use black. And there we go. That looks a little bit better. Not so much. And let's see if we can draw that a little bit better. Okay. And then the graph will look something like this right here. It'll look something similar to that right there. And then so it's going to look something like this right here. So state the domain of f of x equals 1 over x. The function accepts all real numbers except for, well, look, it doesn't take 0 because division by 0 is undefined. So the function domain is as follows. X is less than 0 or x is greater than 0. In set notation, x such that x is not equal to 0. In interval notation, where the symbol u means union, negative infinity to 0, union 0 to positive infinity. Determine the end behavior of f of x. All right, first let's complete the tables. So if x is 100, that would be 1 over 100, which is 0.01. 1 over 1,000 would be 0.001. And 1 over 10,000 would be 0.0001. And that's x increases without bond. X decreases without bond. What we got? Negative 1 over negative 100, that would be negative 0.01. That would be negative 0.001. and that would be negative 0.0001. This right here, remember you saw that it was going, it was getting went down here like this, and as it went out, it got closer and closer to the x-axis. That's it. At 100, it's 0.01. At 1,000, it's 0.001. And at 10,000, it's almost touching. Over here, it went like this. And it's like this. Turn it over soon there. And then as it gets out, it gets closer and closer. Next, summarize the results. As x approaches infinity out here, as x approaches infinity way out here, f of x approaches 0. Okay? As x gets out here and approaches negative infinity way out here somewhere, it's going to approach 0. All right? Good. Be more precise about the end behavior of f of x equals 1 over x and determine what this means for the graph of the function. You can be more precise about the end behavior by using the notation f of x equals, or f of x approaches positive infinity or positive 0, which means that the value of f of x approaches 0 from the positive direction. That is, the value of f of x is positive as it approaches 0. In this notation, and the notation f of x approaches 0 negative, which means the value of f of x approaches 0 from the negative direction. So the end behavior of the function more precisely summarized as follows. As f of x approaches positive infinity, or as x approaches positive infinity, f of x approaches 0 from the positive side. As x approaches negative infinity, f of x approaches 0 from the negative side. The end behavior indicates that the graph of f of x approaches but does not cross the x-axis. It approaches, but it does not cross the x-axis. So that axis is an asymptote for the graph. D. Examine the behavior of f of x equals 1 over x near x equals 0 and determine what this means for the graph of the function. First, complete the tables. As x approaches 0 from the positive side, x and 1 over 0.01, that would be 100. And that would be 1,000. And that would be 10,000. Okay? As x approaches 0 from the negative direction, that would be negative 100. That would be negative 1,000. And that would be negative 10,000. Next, summarize the results. As x approaches 0 from the positive side, f of x approaches positive infinity. As x approaches 0 from the negative side, f of x approaches negative infinity. All right, let me draw you a little graph over here. Let's see. And then we got this right here. Let's see. Okay. As x approaches 0 from the positive side, okay, as it's going this way here, what happens? Well, it does that turn, so it never actually gets to 0 and then shoots up this way here. Okay? And then as x approaches 0 from the negative side, so as it comes this way here, what happens? It gets closer and closer to the y-axis, or the y-axis, but it never actually touches it. The behavior of f of x equals 1 over x near x equals 0 indicates the graph of f of x approaches but does not cross the y-axis. So that axis is also an asymptote for the graph. Graph f of x equals 1 over x. First, determine the sign of f of x on the two parts of the domain. When x is a negative number, f of x is a negative number. When x is a positive number, f of x is a positive number. Next, complete the tables. Well, if x is 2, then y would be negative 1/2. If you put the negative 2 in there for the x, that would be negative 1. And then negative 1/2 would be negative 2. So let's graph that. X is negative 2, and then that would be 1/2 right there. And then negative 1 would be right there. And then 1/2 and negative 2 would be right there. So it's going to look something like this right here. And there we go. Let's take a look at this. All right, if x is 1/2, then that means y would be 2. If x is 1, then y would be 1. And if x is 2, that means y would be 1/2, putting the 2 in for the x. So we got 1/2, 2. We have 1, 1. And we have 2, 1/2. And that's going to look like this right here. All right, and then there we go. All right, finally, use the information from this step and all the previous steps to draw the graph. We just did that. Draw asymptotes as dashed lines. So we'll draw the asymptotes. And then dashed lines, and we'll make them red. So the asymptotes are going to be right here and right there. Okay, and if you'll notice, that's the x and the y-axis. So those are the asymptotes. It gets close to those lines, but it never actually touches them. State the range of f of x equals 1 over x. State the range of f of x equals 1 over x. The function takes all real numbers except 0. So the function's range is as follows. As an inequality, y is less than 0 or y is greater than 0. In set notation, y such that y is not equal to 0, and in interval notation, negative infinity to 0 and 0 to positive infinity. But that doesn't include 0, just right up next to it. G, identify the intervals where the function is increasing and where it is decreasing. Well, this function is never increasing. It is never increasing. It is never increasing. The function is decreasing on the interval on the interval, and that would be negative infinity to 0 and 0 to positive infinity. Now, let me draw you a little thing here. It's kind of crooked. Draw you a little graph here. Why is it never in decrease? Okay. It starts out here and it goes, and then see how that's decreasing. All right. Starts up here and then it's decreasing, getting closer and closer to 0, but never crossing. Determine whether f of x equals 1 over x is an even function, an odd function, or neither. Remember how we do that? We say f of negative x equals, and that would be 1 over negative x. Well, 1 over negative x equals negative 1 over x, which is negative f of x. So it is an odd function. It is an odd function, How does a graph of f of x equals 1 over x show that the function has no zeros? Well, if we graphed it, right? And you saw it never crosses the x-axis. It never crosses the x-axis. It never crosses the x-axis. All right, good. A graph is said to be symmetric about the origin, and the origin is called the graph's point of symmetry. If for every point xy on the graph, the point negative x, negative y is also on the graph, is the graph of f of x symmetric about the origin? Okay. And is the graph of f of x equals 1 over x symmetric about the? Yes. And let me show you. Let's graph it. So let's go to graphs. 1, control, divide, x, and then press enter. All right, look, there it is. Okay, for every point xy, there's supposed to be one negative x, negative y. So control T, let's go to our table. We've got 1, 1. Let's look and see if we got negative 1, negative 1. We got 2, 1/2. See if we got negative 2. We got negative 2, 1/2. And then, well, let's mix it up. 3 and negative 1/3. And we got 3 and positive 1/3. Let's roll on down here. Let's go to 10. You got 10 and 0.1, so we should have 10 or negative 10 and negative 0.1. And you can do this all day. You can do that all day. All right. So yes, and because for every point xy, because for every point xy, you have a point negative x, negative y. All right. Give any lines of symmetry for the graph of f of x equals 1 over x. And to do that, let's see here. Let's do this like this, and then we'll get black. And let me draw. So we got this, And we got that. All right. And here is, it's going to kind of go like that, maybe. And y'all know, art's not my deal. I wish. So that's that right there. Now let's see. Graph any lines of symmetry for the. So let me see here. If we were to draw and I'm going to do them with a dotted line here, and if you were, look at there. All right. If you got a point over here, you got a point over there. You see where the X and the Y. So that's the Y equals X line. Y equals X line. So it's symmetric about the Y equals X line. And also let's take a look over here. And when it not, it's also symmetric about the Y equals negative X line. Y equals negative. So it's symmetric about the Y equals X line. It's symmetric about the Y equals negative X line. And it's also symmetric about the origin, which that's not a line, but either way, it is still symmetric about it. Because you got this point here, and then you got that point there. Graphing simple rational functions. When graphing transformations of f of x equals 1 over x, it helps to consider the effect of the transformations on the following features of the graph of f of x. The vertical asymptote x equals 0, the horizontal asymptote y equals 0, and two reference points, -1, -1, and 1, 1. The table lists these features of the graph of f of x and the corresponding features of the graph of g of x. Note that the asymptotes are affected by the parameters h and k, while the reference points are affected by all four parameters. So, remember that h is horizontal, and the k is the vertical. The A, vertical stretch or vertical compression, and the B is horizontal stretch or horizontal. So, and then you can follow that right there. And let's roll on down here. Let's roll down here to B. Okay. Go ahead and stop the video and read through A and get a little practice with it. And then we'll do B together. Glad you're back. G of x equals 1 over 2 times x plus 3 minus 1. So let's see here. What is our h? H equals 3. That's our h. Okay. And it's actually negative 3 because remember that's x minus h. So that's going to be negative 3. What's our k? Our k is negative 1. K equals negative 1. The transformation of the graph of f of x that produces the graph of g of x are a horizontal compression by a factor of 1/2, a translation of 3 units to the left and 1 unit down. Now, hold on, this has a 2 there, but that has a 1/2. I'm not sure. Well, that's because it's, remember this right here, 2, let me do it in a different color. This is 2 equals 1 over b, right? 1 over b, because that's what's supposed to be. So times both sides by b, and you get 2b equals 1. Divide both sides by 2, and you get b equals 1/2. So that's how they get the 1/2 there. Okay? Note that the horizontal compression by a factor of 1/2 and the translations of 3 units to the left affect only the x-coordinate on the points of the graph of f of x, while the translation of 1 unit down affects only the y-coordinates. All right, good. So here we got this stuff here. So the vertical asymptote, it was x equals 0. It is now x equals -3. Okay, -3. The horizontal asymptote was y equals 0. It is now y equals -1. Do you see on the graph, do you see on the equation where I'm getting these? All right, so let me roll it up now. So this was -1, and let's see, this is -3. Okay, so now I've got I've got -1. And I got -1 here, and I got -1 there. Okay, so 1/2 times -1 minus 3, and that's your -3. 1/2 times -1 minus 3. Well, that's going to be -1/2 minus 3, which is 6/2. -1. That's going to give you -3.5 or -7/2. -7/2. Good. Now you have 1, or that's going to be -1, -1, and that's where I'm getting the -1. -1 minus 1, and that right there, that's this one right here. Those two. Okay. So -1 minus 1, that's going to give you -2. Okay. Now let's see here. We've got 1/2 times 1, and I got that from right there. 1/2 times 1 minus the 3, which I got from there. So that's going to be 1/2 minus 3, or that's going to be -2.5 or -5/2. That's going to be -5/2. Okay. Now we've got 1, this 1 minus 1, that's going to give you 0. Okay. And I wonder if I punch it up a little bit. Yeah, okay. So let's see here. We've got, it went from -1, -1 to -7/2, -3.5. -3.5. 1, 2, 3.5. And then, that's not transformated yet. Okay. Inequality. X is less than -3. X is greater than -3. Y, we're still doing X. X such that X is not equal to -3. In interval notation, it'll be infinity to -3, and -3 to positive infinity. Cool. Now let's do the range. And I did the range in red, I guess. That's going to be y is less than -1, or y is greater than -1. Y such that y is not equal to -1, and -infinity to -1, and -1 to positive infinity. All right. Did it grab? No, they didn't grab. All right. Your turn. Identify the transformation of the graph of g of x, or f of x equals 1 over x, that produce the graph of the given function g of x. Then graph g of x on the same coordinate plane as the graph of f of x. by applying the transformations to the asymptotes of x equals 0 and y equals 0 to the reference points -1, 1, and 1, 1. So let's take a look at what we got. I don't know. I don't know how that, I didn't mean to do that. Okay, so here we got. First, let's find our h. What is our h? Our h is, I think before I did blue for h. So h equals -1. Okay, and I got that right there. Okay, good. So that is going to be our horizontal asymptote, right? That's going to be our horizontal asymptote, or our vertical asymptote. X equals -1. So a vertical asymptote. That's our vertical asymptote. X equals -1. I would do that. So let's go ahead and draw that real quick. So let's find -1. So that's going to be, and I want blue, and we'll use a dotted line. Okay. Now our horizontal asymptote, our horizontal asymptote, we know that k equals -3 right there. So that's going to be our horizontal asymptote. And it's going to be y equals -3. So y equals -3. And let's draw that. So you got 1, 2, 3. That's going to be -3 right there. And there we go. Mine might be slightly crooked. Be all right. So now we got our asymptotes, a horizontal asymptote and our vertical asymptote. Now let's do the transformation with the points. We've got -1, -1, right? Starts out -1, -1. And then we're going to make some transformations. So -1, -1, this becomes -1, that's going to be -1 -1, -1. Okay. And then we got our A. Our A is 1/2, and let's see. A equals -1/2. So the negative is going to flip it over the x-axis, and the 1/2 is going to vertically compress it. So we'll put -1/2 right here, -1/2, -1/2, and then we're going to multiply that by our -1, and then we're going to subtract 3 from it, -3. So what is our new point? -1 -1 is going to be -2. -1/2 times -1/2, that's going to be +1/2, -3 or -6/2, that's going to give you -5/2. So -2, let's see, 1, 2, and then 5/2, that's going to be 2.5. 1, 2.5, that's going to be right there. Okay, that's our new point. 1, 2, and then -5/2. All right, and now let's try the 1, 1. 1, 1. You got 1, 1, and we've got -1, and then we have -1/2 times 1 -3. So what's our new point? 1 minus 1 is 0. -1/2 times 1 is -1/2. -6/2, that's going to be -7/2. So we're going to have 0, 3.5. That's going to be, or -7/2. That's going to be right there. Okay, so our graph is going to be like this. And then like that. And what was the domain going to be? The domain, it says to write it all three ways. So domain. The domain will be, and let's see, we're going to have x such that x is not equal to 1, -1. We'll have x is less than -1 or x is greater than -1. And negative infinity, and I don't know why I did a bracket, I meant parentheses, to -1 union -1 to positive infinity. Range, we have y such that y is not equal to -3. We have y is less than -3 or y is greater than -3. And we have negative infinity to -3 union -3 to positive infinity. Great. That's number 4. Why don't you try number 5? Stop the video and try number 5, and then when you come back, we'll do it together. Great, glad you're back. So let's start this off. First, let's find our h. H equals 2. So we know our vertical asymptote is x equals 2. X equals 2. So let's draw that. And x is 2. So that's going to look like this. Great. We know our k is 1. So our horizontal asymptote is y equals 1. And we'll go ahead and draw that. And there we go. Right, the next step is to make our transformations. And we'll start off with -1, -1. And then don't forget about 1, 1. And we'll make our little moves here. What do we got? Okay, so we've got a b this time. We have a b. Let's do it over here. B equals, remember that's supposed to be 1 over b. 1 over b equals -1/2. Okay, so if we multiply both sides by b, we get b times b, and we get 1 equals -1/2 b, right? And then if we multiply both sides by -2, we get -2 equals b. So b is -2. Now, the b affects the x. So we're going to have -2, okay? And we're going to multiply that by the -1, right? And then we got +2 for that transformation. Now, we've got -1, and we're going to add 1 to that. +1. +1. So -2 times -1 is 2. 2 plus 2 is 4. And then -1 plus 1 is 0. So we've got a point 4. Let's see. 1, 2, 3, 4, 0 is going to be right there. All right, good. Now let's do this next one here. Again, we got -2 times this 1 here. And then we got to add 2 to that. +2. And then we have 1 plus 1. So where's our new point? -2 times 1 is -2, plus 2 is 0. 1 plus 1 is 2. So we've got 0, 2. That's going to be right there. That's going to be right there. Okay, so our new graph will look something like, remember you got these right here, so it's going to be out here like this. Right, like that. And this is going to be like that right there. Okay. All right. Domain. We got our domain. And it wants us to write it in all three ways. So you can have x is less than 2 or x is greater than 2. You're going to have x such that x is not equal to 2. And you have -infinity to 2. And then 2 to positive infinity. Range. And we'll do this in red. We're going to have y is less than 1 or y is greater than 1. Y such that y is not equal to 1. And -infinity to 1 and union. And then 1 to positive infinity. All right, great job. Okay, rewriting simple functions in order to graph them. When given a rational function in the form f of x equals mx plus n over px plus q, where m is not equal to 0 and p is not equal to 0, you can carry out the division of the numerator by the denominator to write the function in the form g of x equals a times 1 divided by x minus h plus k, or g of x equals 1 divided by 1 over b times x minus h plus k. Rewrite the function in the form g of x equals a times 1 over x minus h plus k, or g of x the other way, and graph it. Also state the domain and range using inequality, set notation, and interval notation. So go ahead and read A and follow along. It's not real hard. And then when you get back, we'll do B. Glad you're back. So what do we got here? G of x equals 4x minus 7 divided by -2x plus 4. Use long division. So negative 2x plus 4, and then let's see, that's going to give you negative, that's going to give you 4x, and then that's going to give you negative 8, so that's going to make that a positive 8. So we're going to have a positive 1 here, a positive 1. So the quotient is negative 2, and the remainder is 1. Using the fact that the dividend equals the quotient plus remainder divided by divisor, we're going to get negative 2 plus 1 over negative 2x, and then we'll take the negative 2 out of there, and that'll give us negative 2 times x minus 2. Okay. Now we're about to make us an equation here. We're about to make us an equation. The graph of g of x has a vertical asymptote x equals 2. The horizontal asymptote y equals negative 2 in reference points. So let's see, negative 1/2 times negative 1 plus 2, and negative 1 minus 2. So let's see, negative 1/2, that's going to be positive 1/2 plus 2, that's going to give you 2.5. 2.5. And negative 1 minus 2 would give you negative 3. Negative 1/2 times 1 plus 2. Okay, that's going to give you 1.5. 1.5. And then 1 minus 2 gives you negative 1. All right. So the domain is going to be x is less than 2 or x is greater than 2. X such that x is not equal to 2. And then negative infinity to 2, union 2 to positive infinity. Great. Now, what about the range? Well, y equals negative 2, so y is going to be less than negative 2, or y is going to be greater than negative 2. Set notation, set notation. Y such that y is not equal to 2, and then the interval notation. All right, good. And then I guess it wants us to graph it. So let's graph it. We found the new points. Let's see. First, let's do our horizontal asymptote and our vertical asymptote. So we've got black here. Let's make that red. And we got y equals negative 2. So that's going to be right here. And then we got our vertical asymptote, y equal or x equals 2. That's going to be right there. And let's plot our points here. Plot our points. We've got a point at 2.5, negative 3. 1, 2.5, negative 3 is going to be right there. And then 1.5, 1.5, and negative 1 is going to be right there. So we go like this. There we go. Good deal. In part A, the graph of g of x is the result of what transformation of the graph of f of x equals 1 over x. It's a reflection of the graph of f of x across the x-axis in a translation 1 unit to the right and 3 units up. So it's a translation of 1 unit to the right and 3 units up. In part B, the graph of g of x is the result of what transformation of the graph of f of x equals 1/2? Well, let's see. There was a horizontal. That looks terrible. Horizontal compression by a factor of 1/2. There was also a reflection over the y-axis. A translation, 2 units to the translation. 2 units to the right. And 2 units down. Great. All right. Your turn. So we're given this. We're rewrite the function of the form either one and graph it. Also state the domain and the range. So let's see here. We have x plus 2, and that's going to go into 3x plus 8. We have x plus 2, and that's going to go into 3x plus 8. So 3 times x is 3x. 3 times 2 is 2. 3 times 2 is not 2, it's 6. We're going to subtract that. Okay, those cancel out. And you got 8 minus 6. That gives you a positive 2. So we can rewrite that as g of x equals, and that's going to be 3 plus 2 over x plus 2. Now you're used to seeing it as 2 over x plus 2 plus 3. Notice this doesn't have a 1 in, so we've got to put the 1 out front. We got 1 over x plus 2 plus 3. Okay, so we're going to have an a. Let's see, we have a equals 2. What does that do? What does the 2 do? Okay, that's a vertical stretch. And then, well, let me don't use blue because I've been using a equals 2. And then we're going to have a vertical asymptote of x equals -2. So let's go ahead and draw that. A vertical asymptote of x equals -2. And that's going to be right there. Great. And then we're going to have a horizontal asymptote of x equals 3, or y equals 3. Y equals 3. So let's go ahead and draw that. 1, 2, 3. It's going to be right there. That's a little high. All right. Good. So y equals 3, x equals 2, and I need to change. Let's make that, put the 2. So they're color coded, and now we know where they're at, right? So let's do some transforming. We've got, remember those points, -1, -1, and 1, 1. Okay, so this will become, and we've got, is anything being done to the x? Well, yes, we're subtracting 2 from it. So you got -1 minus 2. And then, now, this a here, that always works on the y. So you got 2 times negative 1, and then we're adding 3 to it, plus 3. And let's see it. Negative 1 minus 2 gives you negative 1 minus 2 gives you, and that's going to be negative 3. And then 2 times negative 1 is negative 2, plus 3 gives you 1. So you got negative 3. Let's see, from x, that's 1, 2, 3, and then 1. That's going to be right there. All right, good. Now, what are we doing here? We've got 1 minus 2. That's the 1 minus 2. And then we've got 2 times 1 plus 3. And what does that get? 1 minus 2, that gives us negative 1. Negative 1, okay. And then 2 times 1 is 2, plus 3 is 5. So we got negative 1, 5. And that's going to be right there. Okay, so let's go up here and draw that. So we've got and then we've got and then we've got to state the domain, and it wants to do it in all 3 ways. So we've got the domain and range. So the domain as inequalities. X is less than negative 2. X is greater than negative 2. You got X such that X is not equal to negative 2. And you've got negative infinity to negative 2 union. And then you got negative 2 to infinity. Range. You've got y is less than 3, y is greater than 3. You've got y such that y is not equal to 3. And you've got negative infinity to 3 and 3 to positive infinity. And I probably ought to put positive over here as well. All right, great. Writing simple rational functions. Okay, you can go ahead and read that and follow along with A. And when you get back, we'll do B. Write the function whose graph is shown. Use the form g of x equals 1 over b times x minus h plus k. Since the graph's vertical asymptote is negative 3, okay. So the vertical asymptote here is negative 3. Let's go ahead and graph that. Okay, so that tells us something. Okay, that tells us that x equals negative 3. That says our h is negative 3. Remember that? If x is negative 3, h equals negative 3. Good. And then we have a horizontal asymptote. Right across through here, and that was supposed to have been red. We have a horizontal asymptote right there, and that's what we have, a horizontal asymptote, and that's negative 1. That looks like negative 1. So that's y equals negative 1. So our k is negative 1. Since the graph's vertical asymptote is x equals -3, the value of h is -3. Since the graph's horizontal asymptote is -1, the value of the parameter of k is -1. Substitute these values in the general form, so you got -1 here, and I already put it in there. Now use one of the points such as -5, 0 to find the value of the parameter. Okay, so we got -1 in there, we got -1 there. Okay, g of x, and then you put the 0 in for the y and the -5 in for the x, and it looks like they're adding 1 to both sides. They got 1 equals 1 over b times -2. So they multiply both sides by this right there, and they got 1. Now I would multiply both sides by b. So you get -2 equals b. And see, that was a 1 from before. All right, so b equals -2. So b equals -2. B equals -2. So g of x is 1 over -2 plus, that's -1. So that's going to be -1/2. Good, good. Discussion. In parts A and B, the coordinates of a second point on the graph of g of x are given. In what way can those coordinates be useful? Well, you can use those coordinates as a check on the correctness of the equation by substituting those coordinates into the equation and seeing if you get a true statement, which is kind of like what we did just a minute ago. I keep hitting that somehow or another. I'm not sure how. 10. Write the function whose graph is shown. Use the form g of x equals a times. Okay, so what did we do before? Well, let's notice here we've got horizontal right there. We have a vertical right here, and that gives us something. Let's see, the vertical, and that's what, 1, 2. So h is -2. H is -2, and the horizontal is 1. So k equals +1. Okay. So what do we got? We've got g of x equals, and we're going to be looking for the a. We got 1 over x minus -2, and plus 1. So we're going to be looking for this right here. It gives us a couple of points, -3, 5, and -1, -3. Let's use we'll use the -3, 5. Okay, it doesn't matter. -3, 5. We'll use this one here. So we got 5 equals, and then you got a, because that's what you're looking for, a, and you got 1 over, and then here for the x, we're going to put the -3, x minus negative, or x plus 2, and then plus 1. So 5 equals a. We just got some arithmetic to do. And then what do we got? That's going to be 1 over negative, that's going to be -1. Okay. Plus 1. Well, let's subtract 1 from both sides, and we get 4 equals a times -1. So multiply both sides by -1, and you get negative 4 equals A. Negative 4 equals A. So our equation, so g of x will be negative 4 times 1 over x plus 2. Running out of room there. Let me do it a little bit better. Do it a little straighter. So g of x equals, that's going to be negative 4 times 1 over x plus 2 plus 1. Write the function whose graph is shown. Use the form. Okay, we're going to do the exact same thing that we did before. Okay, nice and easy. We have vertical asymptote here, and we have a horizontal asymptote there. Good. So let's see. We've got, let's see, 2, 3, 4. So h equals 4, and then k equals, and then that's going to be negative 3. So we got g of x equals 1 over, and that's going to be 1 over b, and then x minus 4, and then minus 3. Okay. We got 2 points here to choose from. It really doesn't matter which one you choose. This time I'll use 3.5 and negative 4. So I got negative 4 equals 1 over b times 3.5 minus 4 minus 3. Add 3 to both sides. I got negative 1 equals 1 over b, and that's going to be negative 1/2. Multiply both sides and by that, and I've got negative 1 times 1 over b times negative 1/2 equals 1. So let's see here. Do that arithmetic, and you've got negative cancel out, and 1 times 1 is 1, and then b times b is 2b equals 1. Multiply both sides by 2b. 1 equals 2b, so b equals 1/2. All right, b equals 1/2. So let's go up here. B equals 1/2. So g of x equals 1 over 1/2. Was it negative? No. And then you've got x minus 4 minus 3. Well, you got to do a little arithmetic there, and that's going to give you 1 over 2 times x minus 4 minus 3. All right, good. Modeling with simple rational functions. Go ahead and read through A, or read on down here. I guess read A. Mary and some of her friends are thinking about renting a car while staying at the beach resort for a vacation. The cost per person for staying at the beach resort is $300, and the cost of the car rental is $220. If the friends agree to share the cost of the car rental, what is the minimum number of people who must go on the trip so that the total cost for each person is no more than $350. Identify the important information. The cost per person for the resort is, what did it say up here? $300. The cost of the car rental is $220. The most that each person will spend is $350. Okay. Create a rational function that gives a total cost for each person. Graph the function and use the graph to answer the question. Let P be the number of people who agree to go on the trip. Let C of P be the cost in dollars for each person. So C of P equals 220 over P. 220. That's the cost of the car rental over P plus $300. That's the cost of the resort. Okay. Graph the function, recognizing that the graph involves two transformations of the graph of the parent function. A vertical stretch by a factor of 220. A vertical translation of 300 units up. Also draw the line C of P equals 350. Okay, let's do this on a graphing calculator. So we've got new document, no, graph, control, divide, and we've got 220 over x. Over x, and then that was plus 300, right? Plus 300. And hit enter. And then we wanted the total cost to be less than 350. And graph that. Now we're going to have to move out. So menu, 4. Okay, so there we are. And I want to, let's see, I'm going to clean this up. Menu, 4, 1, and see negative 309, we don't need that. How about negative 2? And then I'm thinking maybe at the most 10. Okay. So now we can see that point pretty clearly. Menu, 6, 4, and as you, let's see, 4.4. Okay, good. Okay, that's going to make it a little easier. The graphs intersect between P is 4 and P is 5. Remember, it was 4.4. So the minimum number of people who must go on the trip in order for the total cost for each person to be no more than 350 is 5 people. Can't have 4.4 people go. Got to be 5. Check the solution by evaluating the function C of P. Since C of 4 is, and that's 355, is greater than 350, and C of 5 is 344. The minimum number of people who must go on the trip is 5. Where did I get those numbers from? Let's see. Control T. C of 4 is, and I just got them right out of the table there. Control T makes it a little easier. Justin has purchased a basic silk screening kit for applying designs to fabric. The kit costs $200. He plans to buy t-shirts for $10 each, apply a design that he creates to them, and then sell them. Model the situation with a rational function that gives the average cost of a silkscreen t-shirt when the cost of the kit is included in the calculation. Use the graph of the function to determine the minimum number of t-shirts that brings the average cost below $17.50. So let's see here. The kit costs $200, so that's going to be plus $200. And he plans to buy t-shirts at $10 each. So we've got f of x equals 200 over x plus $10. Okay. All right. And we'll put g of x, we want to be at 1750, right? 1750. So let's go to our trusty rusty calculator. New document, no graph, and I've got $200. Control divide x plus 10. And we'll hit graph on that. Ooh, I don't even see it. And then tab, we want 1750, right? 17.5. Enter. I don't see either one of those. There's that one there. There's my spot. There's my spot. And, okay, so I need to find that spot there. Menu, 6, 4, and there it is. It says 26.7 and 17.5. So what do we got going here? So C of 26, C of 27. C of 26, Control T, 26. 26 is 17.69 equals 17.69, and C of 27 is 17.41. 17.41, and those are approximates. 17.41. Those are rounded. Okay, so, and we figured out it was 17.7. So he's gonna wanna sell 27 t-shirts to get that average cost below $17.50. All right. Compare and contrast the attributes of f of x equals 1 over x, and the attributes of g of x equals negative 1 over x. Okay. That's not hard at all. Both functions have domain and ranges that approach 0. They both have x and y asymptotes. They both have x and y axes asymptotes. The difference is they approach the asymptotes from different directions. State the domain and range of f of x equals a times 1 over x minus h plus k using inequalities, set notations, and interval notes. So the domain. The domain. Well, that's going to be x is less than h, x is greater than h, x such that x is not equal to h, and negative infinity to h, and h to positive infinity. Range, y is less than k, y is greater than k. And y such that y is not equal to k, negative infinity to k, and k to positive infinity. So y'all thought that was going to be hard, didn't you? Easy peasy. 15. Given that the model C of P equals 100 over P plus 50 represents the total cost in dollars for each person in a group of people when there's a shared expense and an individual expense, describe what the expression 100 over P and 50 over P represent. Well, the individual expense would be the $50. Is the $50 or the 50. The shared expense is 100 over P. Because, right. Describe the transformations you must perform on the graph of f of x equals 1 over x to obtain the graph of f of x equals a times 1 over x minus h plus k. Well, let's see. Remember the h moves, moves left or right, depending on whether it's positive or negative. K moves up or down, depending on its sign. And then A is a vertical compression or stretch. Good deal. Folks, that's it. Enjoy your evening. I'll see you tomorrow in class.